So yesterday we talked about graphing and the basics of the graph and how the coordinate system works, and about using tables to graph generic equations. And then we even looked more specifically at lines and how to tell whether an equation is going to form a line on the graph just by looking at it. So today I want to concentrate more on actually graphing those lines. We had said that looking at an equation, as long as it did not have, let me get my content going here, it doesn't look like it's sending, there we go. If it did not have any powers on the variables or roots, if the variable was not a power itself, and if we weren't dividing by the variable, then it created an equation that would make a straight line on our graph. So probably the simplest linear equation we can get is y equals x. And this equation has a couple of traits. One is it displays the trait that all equations, all graphs start at the origin, right here in the center. And for this equation, that's very true. If x is 0, y is 0. So we have a point right there at the center. From there, if we pick values for x and calculate what y has to be, we can just plot a couple of points like we did with the tables on Wednesday. Quickly finish off my graph here. For example, if I were to pick x equals 2, y would have to equal 2, giving me a point right there. Or x equals negative 3, y would equal negative 3, giving me a point right there. Creating a line across the graph like this. That is the simplest linear equation we can create. And as I said, it gives us those standard traits of going through the center and having that 45-degree angle across the graph, assuming I do that straight, which I didn't quite do. Anyway, the next simplest linear equation, some of the things we can do to make this an equation a little more complex, we might be able to add something to it, like x plus 2. Still going to be a line, still no powers or roots or anything like that on the variable. No dividing by the variable. But what's happening now is if x is 0, 0 plus 2 is 2, y is 2. And as we substitute in those points, what we find, we get a line that it goes across the graph at the exact same angle as that blue line. It's just shifted up 2 points. So it no longer goes through the origin anymore. It goes up 2. It goes through 2 units higher than that. Likewise, we can subtract y equals x minus 3 is going to do the same thing. Just move everything down 3 units. We get a line that goes across at the same angle. Just slid down 3. Other things we could do to make this graph a little more complex, we could multiply, like y equals 2 times x. Now here we're back to going to the center, because when x is 0, y is 0. We're back to the origin, back to where everything starts. But now if x is 1, 2 times 1 is 2, y is 2. And as we keep adding points to that, if x were negative 2, y would be negative 4. Now we're back to going through the center, like I said, but we go across the graph at a different angle. There's really only 2 things, as we've seen here, that can happen to change our graph. We have this adding or subtracting that goes on back here that moves it up or down. As we said, all graphs start at the origin. But that number then tells us that we're going to move the starting point up or down from the origin. So that minus 3 means we go down 3. So this graph starts down here, 3 units below the origin. The number that multiplies the x, most of you will know, is called the slope. The slope is a ratio of rise to run. Now that doesn't look like a ratio because it's just a 2, but we can make it a ratio or make it a fraction by putting it as 2 over 1. So what that is telling us is from this starting point here, we're going to rise 2. So we go up 2 to there and run 1. So we go over 1. The run is in the positive direction, left to right. Rise is also positive direction, up or down. So if I were to graph y equals 3/4 x plus 1. Well, same thing here. The plus 1 is telling us that instead of going to the center, so the 1 is telling us instead of starting at the origin, we start out up 1 unit. So right there is our beginning point of this graph. And then 3/4 x, the 3/4 is our slope. The top number is the rise. So from there we rise 1, 2, 3. And the denominator is our run. So we run 1, 2, 3, 4. There's our second point right there. Our line goes through that. Or y equals -3/2 x plus 2. Again, the number that's added or subtracted tells us where we start from the origin. So from the origin here, this is saying we start up 2, or +2 on the y-axis. The slope then, the number that multiplies the x, -3/2, is telling us we're going to rise -3. The negative we tend to put with the rise. The run, we try to always go left to right in the positive direction. So -3/2 means we're going to go down 3. 1, 2, 3. And then we're going to run over 2. It's a negative slope. As we go from left to right, the graph should always go down. So make sure, the biggest thing a lot of people will do to mess that up is they'll make both numbers negative. So from here they'll go down 3 and then back 2. But if you did it that way, you see that we still have a positive slope. Think of it mathematically, 2 negatives divide to make a positive. So they can't both be negative. You could have done a +3 rise to get to here, but then your run would be negative. Back 1, 2. Would put us on the same line, so we'd get the same thing. But when you're dealing with a negative slope, either the rise is negative or the run is negative, but not both. We could have y equals -2 plus 3x. Now I purposely wrote this in a different order to get us used to it. The -2 is the number that's added or subtracted here. So from the origin, we're going to start out down 2, which is right there. And then the 3x, we're going to make it a fraction. That's 3/1. And it's positive, so from that starting point, we go up 1, 2, 3, and over 1. And there's our line. I'm assuming most of you have seen slope-intercept graphing before. So let's step up to something just a little bit more difficult, or when the equations aren't quite so simple at least. So something like this. Y minus 2 equals 1 minus 1/3 x. All of the equations we've done so far have had y equals, y equals, y equals. And in order to graph them the way we have, by just using that starting point or the y-intercept and the slope, we have to have it in that form. It's called graphing form or slope-intercept form. So we need to get y by itself here. Now in this case, just like when we were analyzing one variable equations, we look at that side of the equal sign that has the y on it, and we ask ourselves what's keeping y from being alone or by itself. In this case, it's the 2. What operation was used to attach the 2? Well, the 2 was subtracted from the y. So to get rid of it, we are going to add 2. Adding 2 gets rid of that piece, leaving us with y. Now when we add or subtract to an equation, we have to do the same thing to both sides. So we're going to have to add 2 to the other side of the equation as well. But when we add or subtract, we only have to add it to one piece on each side. So for example, over here, we have to add 2, but we just pick one of the spots. Now we can't add it to the -1/3 x because they don't have the same name. We have to add the 2 to the 1. So 1 plus 2 is 3, and we still have the -1/3 x. So now here, the 3 is our starting point. 1, 2, 3 right there. And from that -1/3, we're going to go down 1. So we're going to rise -1 and then still run 3 in the positive direction. So there's our line. with a y-intercept of 3 and a slope of negative 1. So on this one, again, y is not by itself. It's got the 2 there. The 2 is multiplied, so we have to get rid of it by dividing. So we're going to divide by 2 to get y all by itself. As always, we have to do the exact same thing to the other side of the equation. But when we multiply or divide, we have to do it to each piece on each side of the equation. So we're going to divide this whole side by 2. Now a little trick. First of all, whenever I see the x, we think of it as a 1x. And when we're dividing that x by a number, we're going to go 1x divided by 2. We're just going to go 1 over 2 to make it a fraction, and then x. And then positive 4 divided by 2 is a positive 2. So that's telling us we start out at 2, right there, and a slope of 1/2 means we go up 1 over 2. Now let's look at a little bit more complicated yet. We might have 3y plus 1 equals 2x minus 2. So again, we look at the side that has y on it, and now we have to get rid of the 3 and the 1. Well, the 3 multiplies the y, the 1 was added. So again, we take it apart, we have to go in the reverse order. So we are going to subtract the 1 first. That's gone, leaving us with 3y over here. When we subtract, we only have to do it to one piece on each side, so I'm going to subtract the 1 from the negative 2. So the 2x doesn't change. Negative 2 minus 1 is a negative 3. And then I have to divide by 3 here. When I divide every piece by 3. So 2x divided by 3 is just going to be 2/3 x. Negative 3 divided by 3 will be a negative 1. And now I go to graph it. I'm going to start at negative 1. 2/3 x means I go up 2 over 3. We might have something like this. We still need to get y by itself. We have the negative 2 here, and you got to remember that's a negative 2. We're not subtracting 2. That's a negative 2 multiplying the y. And we have the 3x, which is added. Now, the fact that there's an x there tends to confuse people, but it doesn't change anything. The 3x is just something that was added to the y, so it's something we have to get rid of. So we're going to start by subtracting the 3x, and it's gone, giving us negative 2y over here. We have to subtract 3x from the other side. Well, 4 minus 3x is just 4 minus 3x. And then we finish it off by dividing by a negative 2, get y by itself. 4 divided by negative 2 is a negative 2. Negative 3x divided by negative 2. Well, first of all, negative divided by negative will give us a positive. 3x divided by 2 is going to be just 3 over 2 x. So we're going to start out at negative 2. And from there, we're going to rise 3. 1, 2, 3, and run 2. And there we go. I'm going to assume that most of you have seen the slope-intercept graphing before. So I'm not going to do more examples and keep boring you. What I do want to do is look at what these graphs actually mean. For example, if I were to tell you that I have a graph with a slope of 2/3 and a y-intercept of, well, let's go 4. We know that on the graph itself, that means we start at 4. And from there, we use the slope. We go down to over 3. And our line goes through those points. The question is, what do they mean? Well, there's a reason why I only drew this first quadrant of the graph here. Because in reality, in most practical applications, that's all we're really using is that first quadrant. The y-intercept of 4, that starting point of 4, is exactly that, a starting point. It is telling us at the beginning of whatever it is we're graphing, whether we're tracking the volume of fluid in an IV bag. I did that way wrong with the 2/3, didn't I? I was thinking negative 2/3, and I did it, but it's positive 2/3. Sorry about that. So that slope of 2/3 should have gone up 2 and over 3. So we get that line like that. Sorry. So anyway, whatever this is, it starts out at 4. It has an initial value at the beginning of whatever we're doing. It's at 4. The slope then tells us that for every unit of time, now we just went up 2 units and over 3, but we could break it down into single units. If we went over a single unit here, what we'll find is if we went over 1, we actually went up 2/3, the value of the slope. So what that slope is telling us is for every unit of time or every unit of whatever is on our x or independent axis here, the dependent value, which is that vertical axis or y-axis, is increasing by 2/3. So if we have an IV bag that starts at 2 liters of fluid and is flowing at a rate of 0.25 liters per hour. Now let's create the graph. And the equation. So it's starting at 2 liters. That means somewhere up here at 2 liters, we have a dot that starts this. Now the flowing at 0.25 liters per hour, we can handle that a couple of different ways. We could change 0.25 to the fraction of 1/4. Or we could just go, 0.25 up for every 1 unit over. If we treat it as 0.25 over 1, works as well. But the thing we have to remember here is this is the volume of a bag. So it's flowing at 0.25 liters an hour. If what we're showing here is the volume left, that's negative. It's decreasing the volume in the bag. So if I do the 1/4, it's a negative 1/4, which means from that point we're going to go down 1 and over 4 to right there. Extend my line out here a little bit. There we go. So we're going to get a line that looks something like this. And that line, again, it describes the volume in that bag. What we see here is at 8 hours, that bag should be empty. The equation then, it starts at a positive 2, so we got a plus 2 over here, and it's decreasing by 1/4 or 0.25 liters per hour, so minus 1/4 x, where x is the number of hours. We also might have a graph for a medication level in the blood concentration. And let's say I'm just going to give you the graph this time. So here we've got 50 milligrams per deciliter is the concentration there. And down here, this is hours. And let's say we have a graph that looks something like this. The patient has been given, has some medication in their system to begin with, and over time, the level is going to increase. So there's a line. Now notice I'm not going back in this direction because we're starting at 0. We can't go back into negative time. So anyway, to create this equation, we need two things. We need the slope, and we need that starting point, or the y-intercept. Now the y-intercept is usually easiest to get. That's right there. Not at 2, since this is a 50, that would be the 20 milligrams per deciliter. Our slope, if we pick 2 points that we can find on the graph, here and here, if we look at our rise and our run here, we rise from 20 to 30, that's 10 units, and we run 1, 2, 3 hours. So our slope is 10 milligrams per deciliter per 3 hours. Or that can be divided down to 3 1/3 milligrams per deciliter per hour. So if I wanted to write the equation for this, y equals 3 1/3 or 10/3 milligrams per deciliter per hour times x, because x is our time, plus the 20 milligrams per deciliter. Now in practice, if we left out the units here to make this a simpler equation, that's just fine. Y equals 3 1/3 x plus 20 is the equation that describes that. So I want to look now a little bit more at finding slopes from these graphs, and then we want to look at finding slopes just from data points. So let's say that on this graph, we have a line that goes like this. When we have a graph like this where our line goes through these nice definite coordinates for us, or lattice points on our graph, it's fairly easy because we can find those points, we can mark them, and then we can create a slope triangle, a rise and a run between those points. Now we have to be careful not to count the marks, but to count the gaps. There's 1, 2, 3 gaps here. So this has a rise of 3. On the run, there's 1, 2, 3, 4, 5, 6. That way, so it's a run of 6. So the slope here, being rise over run, is 3 over 6. And of course, that can be reduced to 1/3. Not all graphs go through nice coordinates on the axis like this. We may run into graphs that look like this. So in order to do this, we're going to do the same thing, drawing a slope triangle, but now we have to use the axes here. To get from one point to the next, we see we rose 2 units, and the same down here. We see that we ran 5, giving us a slope, rise of 2, run of 5. What we see here, however, let's say we had some coordinates for these points. Let's fill in like this. So this point here would end up being 3, 4. This point here ends up being 8, 6. If we're looking at those coordinates, we see what describes the rise, the vertical change, is the difference in the y-coordinates. There's a difference of 2 there. We had a rise of 2. What describes the run, or the horizontal change, is the x-coordinates. Between 3 and 8, we had a difference of 5. We had a run of 5. So that leads us to something called our slope formula. Where we can describe from 2 points, x1, y1, and x2, y2, we can describe the slope. M is the symbol we use for slope. As y2 minus y1 to get the rise, over x2 minus x1 to get the run. It is important to keep the order in these so that we know whether we have a negative or positive slope. If we sketched them on the graph, of course, we'd know whether it had to be negative or positive, and it wouldn't be such a worry. But if we don't, if we're just doing them from the coordinates, we have to keep track. So let's say we have the coordinates 2, 7, and negative 1, 1. I'm going to label them 0.1 and 0.2 just so that I keep things straight. My slope now is y2, so that's 0.2, the y-coordinate, which is 1, minus y1, so 0.1, the y-coordinate, which is 7, over x2, so 0.2, the x-coordinate is negative 1, minus x1. 0.1, x-coordinate is 2, so negative 1 minus 2. And we can subtract. 1 minus 7 is a negative 6. 1 minus a negative 2. Here's where our negatives come back to haunt us again. We change that into addition. 1, negative 1 plus a negative 2. A little bit easier to see that that's a negative 3. Well, negative 6 over negative 3, both can be divided by negative 3 to give me a 2 over 1. So we have a slope of 2 over 1, or just 2 would be fine. So 7, negative 5, and negative 1, 15. Oops, sorry, did not go 15 there. Negative 1, 3. All right. Yeah, we'll go negative 1, 3. So here, again, I'm going to label 0.1 and 2. My slope. Well, y2, 0.2, y-coordinate is 3, minus y1. So 0.1, y-coordinate, negative 5. Put it in the parentheses just so I don't confuse the negatives. Then on bottom, x2, which is 0.2, x-coordinate is negative 1, minus x1. So 0.1, x-coordinate is 7. So 3 minus a negative 5 becomes 3 plus 5, or 8. 1 minus 7 is, or negative 1 minus 7 is a negative 1 plus a negative 7, or negative 8. 8 over a negative 8 is a negative 1. So negative 1 or negative 1 over 1 would be your slope. So 5, 3, and 13, negative 9. So 0.1 and 0.2. y2 is going to be negative 9 minus y1 of 3 over x2 of 13 minus x1 of 5. So we have negative 9 minus 3 will be a negative 12. 13 minus 5 is 8. So it's a negative over positive. It will be a negative, and we reduce both of those by 4. Give us a negative 3 over 2. So negative 3 halves or negative 3 over 2 is our slope. With that, that's all we have for new material for today. So what I want to do is I want to give you your homework, which is going to be page 226 in the book. 1 through 15, the odds. And also, if you can get in touch with your facilitator at each location to get back your tests so you can look those over. Like I said, if you're one of the locations that the version of Word you have doesn't show my inking, send me an email and I will respond to you telling you which problems you had wrong. And if you can get a chance, also get a copy of that alternative version of the dosage calculation test so you can work through that. And as I said, either Wednesday or Friday next week as you guys get worked through it. We'll take some time to go through it just to make sure you guys have that down. Otherwise, have a great weekend.